All right, good morning, everyone.
Good morning.
Good morning, good morning, good morning. Okay, so let's do a quick little check. Does everyone have a pencil?
Yes.
Sit up straight, back straight. Push your chairs in. Back straight. All right, perfect. Does everyone have a pencil?
Yes.
Does everyone have a board?
Yes.
Does everyone have a marker?
Yes.
Does everyone have a bag with your square units?
Yes.
Okay, perfect. So now what we're going to do is, let's do a quick review. So in the past, we've been going over unknown. We'll be going over, you guys remember unknown and fact family?
Yes.
Okay, so I'm going to put a quick little warm up on the board, and I want you to solve this as best as you can. Nod your head if you understand. Okay, you're going to solve for triangle. You're going to solve for what?
Triangle.
All right, here we go. Go. What is the value of triangle? What is the value of triangle? What is the value of triangle? Please be able to prove to me how you got the value of triangle. Yesenia, prove that. You just have an answer. I need you to show me how you got that answer. All right. So I want you to put triangle equals. What is the value of triangle? Tell me, what does triangle equal? All right, be ready to show your boards in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Show your boards. Show your boards. All right. Look at this board here. Look at this board here. What does she have as triangle?
18.
What does she have?
18.
Okay, first off, let's go back to the problem. Let's go back to the problem. I need your eyes. I need your eyes. I need you to read loud and proudly. Read this problem. Go.
6 divided by triangle equals 3.
6 divided by triangle equals 3. Mackenzie has triangle equals 18. Clap once if you agree. Put an X if you disagree. Ooh. Someone tell me why we disagree with Mackenzie's thinking.
Because 3 times 6 is 18.
3 times 6 is 18. Okay, so if we put an 18 right here, could we read this as 6 divided by 18 equals 3?
No.
Yes or no? We would have to,
We would have to change out the 18 and the 6.
All right, here we go. So what should be your correct answer?
2.
What should it be?
2.
All right, let's regroup, okay? Mackenzie, what is the total? The total is what?
6.
The total is 6. What is the size?
Triangle.
Huh?
Triangle.
Yeah, good job. Okay. What are the groups?
3.
3. Remember, total size groups. What are we doing?
Total size group.
Let's do one more. Erase your boards. Let's go.
PSG.
Remember, total size groups.
PSG.
Total size groups. All right, are we ready?
Yes.
Okay, here we go.
Okay.
Go to work. Go to work. Go to work. Total size groups. That one was division. This one's multiplication. Go to work.
Oh.
Okay. We've gone over this. We've done this for about 2 weeks. So by now, we should be using whatever strategy we need. We have fact family. We got total size groups. All right, we go. Okay, Lauren, how did you get that answer? Prove it. I'm not saying it's right or wrong, but how did you get that answer? Yesenia, I like your work. Makai, I like your work. I want you to tighten up those arrays though. Make sure they're nice rows and columns. Make sure those rows and columns are nice and neat. Okay, let's take about 10 more seconds. Much better, Mackenzie. Here we go. 10, 9, 8, 7, 6, 5. Pause for a second. Pause for a second. Total size groups. Total size groups. Look at this. 4. Is that an array to represent this problem? The array that you were drawing, was that an array to represent that problem? Yes or no? It was? You were about to draw 28 circles in a row? Yes or no? Three, 2, 1. Back straight. Show your boards. We're solving for triangle. Okay, I see you got, is that inverse operation? Okay, good. Show your boards, come on, show me your board. All right, let's read the problem, go.
7 times triangle equals 28.
Square. Is that a square?
No, that's a triangle.
Come on, let's go.
7 times triangle equals 28.
All right, you don't have to scream, read it, go.
7 times triangle equals 38. 28.
What?
28.
28. Here we go. 7 times triangle equals 28. All right, so we're solving for triangle. Yes? Okay, here we go. So triangle. Triangle. What does it equal? Logan, what does it equal? It equals 4. Okay? Can you show an array for this problem?
Yes.
Okay, so let's think about it for a second. Do we know the total?
Yes.
What is the total?
28.
Ooh. The total is 7?
No, it's 28.
Is the total 7?
No.
All right, let's do it. Listen to my question. Turn your ears on. Turn your ears on. Listen to my question. What is the total?
28.
28 is your total. Okay? What is your size?
4.
Which is
No, that's 7.
triangle. Good job, okay? Okay, what are your groups?
7.
7, okay? Now, can you interchange these?
Yes.
Like, could I put a size in a group right there?
Yes.
Yes or no?
Yes.
Okay, so if I do 7 groups,
Okay.
how many are gonna be in each group?
4.
Good job, thank you. What if I did 4 groups? How many are gonna be in each group? 7. So remember, your groups and size, can they interchange?
It's inverse.
What is it?
Inverse.
It's gonna be the what?
Inverse.
But it's not necessarily the inverse though, because remember the inverse is you switch in the what?
What's again? Division.
Division. So you actually speaking about a property. What property is that?
Distinguished property.
Oh, he says distinguished property. Is that distinguished property?
No,
Distributed property. Is that distributed property?
Yeah.
Yes or no? Clap once if you agree. Put an X if you disagree. Ooh, Yesenia has an X. If we swap the factors, is that distributed property?
No.
Which property is that, Yesenia?
I'm for sure commutative.
She says the commutative property. Is she correct?
No,
You say no? Why?
because like if you swap them, they could still be the same.
Well, they can still be the same, right? So if I do 7 times 4, what does it equal?
28.
28. If I do 4 times 7, what does it equal?
28. Because
You guys are
swap
saying, so you're saying this is inverse? You're saying this is the inverse operation?
No. It's but it's supposed to be division.
Pause, listen to my question. Is this the inverse operation?
No.
You say yes. Listen to my question. Is this inverse operation?
No.
Why is it not inverse operation?
Because it's supposed to be division.
Thank you. Remember, inverse operation would be what?
Division.
It would be what?
Division.
Division. So quickly pick up your markers and show me inverse operation. What would be inverse operation of 7 times 4 equals 28? Because Yesenia is right. This is the what property? Commutative. Good job. That's the commutative property. Quickly show me the inverse operation. Get there. 5, 4, 3. Show me inverse. 2. 1. Show your boards. Show your boards. No, you did it again. Total size groups. You have nothing. Get something on that board. Go quickly. Good job. So your inverse operation, it should have been what?
28 divided by 7 equals 4.
Good job. Erase your boards. Get there.
Or to be 28 divided by 4 equals 7.
Good job. I appreciate that. All right, here we go. Get there. Get there. All right, repeat after me. Are you ready?
Yes.
Say, I can
I can
use area models
use area models
to show the distributive property
to show the distributive property
to find the area.
to find the area.
What's another way of saying distributive property? We talked about this.
Break apart.
Say it again.
Break apart.
The break apart. So we're gonna take the distributive property and what are you doing?
Breaking apart.
Breaking apart. Repeat after me. Decompose.
Decompose.
Area models.
Area models.
To find
To find
the area
the area
of each shape.
of each shape.
All right, inside of your bag, you're going to see 2 different colors, okay? You're going to see 2 different colors of square units of what?
Square unit.
Of what?
Square unit.
Good job. All right, I'm going to read a problem to you.
Got it.
And when we read this problem, we're going to do this one together. After we get done doing the one together, I'm going to let you do one on your own. Nod your head if you understand. Okay? Do not touch the bag. I want you to listen to the problem first.
Got it.
All right, here we go. It says, Ayana makes a poster that is 3 feet long
Okay, 3 feet.
and 2 feet wide. Raul makes a poster that is 3 feet long and 1 foot wide. They hang the posters on their classroom wall. What is the total area of both posters? Combined. What is the total area? All right. So first, reach into your bag. Reach into your bag, and let's start with Ayana.
Got it.
Okay. No markers. No markers. You're only gonna use your square units right now. I'll let you know when you can pick your markers back up. All right. Here we go. Reach into your bag. First, I want you to use your square units to show me Ayana's poster. Show me Ayana's poster. It is 3 feet long and 2 feet wide. So show me Ayana's poster. Pick one color. Pick one color. Okay. So when you reach into your bag, I want you to first take out 3 square units. Take out 3 square units. Just pick one color, yes. Do 3 square units, okay? When you have those 3 square units, I want you to put them at the top. So put your 3 square units at the top.
Got it?
Okay? All right. Let me know when you're there. Let me know you're there with a thumbs up. Perfect, you're there. I need you to get there. Listen to me carefully. Listen to me carefully. I only want you to follow my lead today. Follow my lead today. I'm gonna let you do on your own in a few seconds. I want you to follow my lead. All right, take 3 square units, and I want you to put your 3 square units at the top. All right? All right, so now I want you to take another 3 square units and I want you to put it directly underneath that one. Perfect. Okay. Does this represent Ayana's poster?
Yeah.
Yes, it does, because I can go across like so to show my row, and then I'm gonna go here and then here. So you should have 1, 2, 3, and then 1, 2, 3. Yes, which is also 1, 2, 3, 4, 5, 6. So if I asked you what is the area of Ayana's poster, what would you say?
6.
You would say 6 square units. So now I want you to do Raul's. I want you to put, and I want you to create a separation, create a division, and do it right underneath Ayana's.
With another color or the same?
Same color is fine. So don't move Ayana's. Keep Ayana's together. Now do Raul's. Okay, this cannot be separated. It has to be together. Okay. Good. This is good. This is good. This is, oh, should it be 3 or 4?
4.
You say 4? I have 1, 2, 3. All right, thank you. All right, thank you for giving me a thumbs up. Okay, so how many square units should you have in your length?
3.
3, okay? How many in your width?
1.
You have how many?
1.
1. Now pick up your marker. Now pick up your marker. Pick up your marker. Are you ready? Okay. What I want you to do is I want you to label the width. So on the side of your square units, I want you to write 2 feet. Yesenia, your board looks good. Make sure you put feet. You have to give it its units. So it is 2 feet. Good job, Mackenzie. Good job. Yep, put 2 feet. Good job. All right. Good job. Then, for your length at the top, I want you to write 3 feet. I want you to write 3 feet. Take this out, build it first. Okay. This is a strategy that you can use. Okay? You can label your length and label your width. All right? On Raul's, what should you put as his length?
3.
3 what?
Feet.
Don't forget about those units. 3 what?
Feet.
Good job. 3 feet. Good job. And then what should you put as his width?
1 feet.
What is it?
1 foot.
It's actually 1 foot. There you go. Because when it becomes more, then it becomes feet. All right. So now here's a challenge. I want you to find the total area. Write your answer on the whiteboard. You need to find the total area. That was the question.
Both of them combined.
Yep, both of them combined. What is the total area of both of them combined?
9.
I said right on the whiteboard. What is the total area? All right, have your answer in 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Give me a thumbs up when you have your answer. Give me a thumbs up when you have your answer. All right, what is the total for Ayana? I'm going to talk to Lauren. What is the total for Ayana and Raul, Lauren?
That's not my name.
Oh, what's
It's Karen.
Karen? Sorry, my bad, Karen. Sorry.
It is 6 for that one.
Okay, 6 for Ayana, okay.
And 4 for that one.
And you say 4?
No, 3.
And 3, okay? So then what would be the total?
9.
The total is 9. Clap once if you agree. X if you disagree. We all agree? Okay, perfect. Clear your boards. 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 All right, here we go. What?
Squares. Square unit.
No, not those.
What are you talking about?
Parentheses. Yeah.
Oh, yeah, we're going to get to those eventually. You're right. We're going to get to those. Okay, so now I want you to try and do one on your own. Are you ready?
Yes.
All right, here we go. So here's the challenge. Kelsey has a floor mat that is 4 feet long and 3 feet wide. No markers. Listen, Yesenia. Greg has a floor mat that is 3 feet long and 2 feet wide. They put the mats on the floor. What is the total area of the floor? Okay, so here's the thing. I have it already up here on the anchor chart as well. So if you forget, look at the anchor chart right here. All right? So I'm going to read again. It says Kelsey has a floor mat that is 4 feet long and 3 feet wide. Greg has one that is 3 feet long and 2 feet wide. They put the floor mats on the floor as shown right here. What is the total area? All right, I'm gonna give you 2 minutes. Go to work. So in this problem, I want you to use Kelsey in one color, and I want you to use Greg in a different color. Let me say that again. I want you to do Kelsey in one color. I want you to do Greg in another color. Go to work. Go to work. And then what is the total area? I like how you labeled your side length, but you said this is 3.
Oh.
And I only see, no, just don't say, oh, it's 2. You said that this is 3 feet long. This is 1, 2. Is that 3 feet?
Nope.
Okay. Okay. So now I want you to switch over to Greg. Switch over to Greg. Okay, so I want you to pause for a second. You got the 3 feet long part, but then I want you to think about the wide. Is this, how long was it? We got 3 feet long, and then how wide is it?
This Greg's.
Which one? If you're saying this is Greg's, okay, so then how is this Greg's?
Because I gotta take them off.
We'll fix it. Okay, so then we need to turn this. Are we turning the board? Okay, so we need to turn the board. Okay, so now you're saying that this is Greg's, yes? Okay, tell me how this is Greg's.
Because he has 2 as his width
Good job.
and then 3 as the length.
Okay, let's go. So now I want you to label that down. Your work looks good. Yesenia, your work is looking good. All right, let's take about 30 more seconds. Okay, so now I want you to label your side links. This looks excellent. What do you need, baby? Is this complete? Are these complete? Why are these empty? So let's think about it. Kelsey's was 3 feet long and 4 feet wide. So we gotta have 1, 2, 3 feet long, and then we gotta have 1, 2, 3, 4 feet wide. So you gotta finish doing hers first. Okay? So count with me, go.
1, 2, 3.
So this is the long part. Count.
1, 2, 3, 4.
This is the wide. Okay, so let's go. Finish doing it. All right, here we go. Good, good. What's the total area? You stopped. What's the total area? Find the total area. Oh, excuse me. You don't have to say it out loud. I can see. Thank you. Good. You have to do the total area. Okay, stop for a second. I need you to, this has to be done. It's a floor mat. So where are the rest of the square units for this floor mat? All right, 5, 4, 3, 3, 2, 1. Okay, so let's quickly look at this right here. So if I'm looking at this particular one right here, okay, I can draw the square units in here. Now keep in mind, when you take TCAP, are you gonna have these square units in your hand?
No.
No, so you have to use your pencil and actually draw inside of it, okay? Or you can write your numbers on the inside. All right, so if I know this is 3, watch me. Does this show the 3?
No.
Okay, so now I have to make sure that this shows how many columns. 4, watch me.
1, 2, 3,
All right,
4.
does this show Kelsey's floor mat?
Yes.
Okay. Okay, and it'll make 4, right? Okay, does this show Kelsey's floor mat?
Yes.
So this is Kelsey's, right?
Yeah.
Okay, so then this is Greg's. This is Greg's, yes? Okay,
Yeah.
watch. Did I create the 3?
Yes.
All right, so then all I have, do I need to come over to show the 2?
Yes.
All right, here we go. We're gonna come over. And then what is that?
6.
So this is,
6.
okay, and this is Greg's. That's Kelsey's, all right? How many is over here?
12.
12.
6 plus 12.
How many is over here?
6.
6. Yes? Okay. Let me also say this. If you see a question like this on TCAP and it's side by side like this, I just want you to take a pencil and separate them like that. That's all you do. Take your pencil, separate them. You do the area of one side, then you do the area of the, and then what do you do with them?
Combine them.
Combine them. Clear your boards. Let's do one more. Clear your board. Now we're about to get into distributive property.
Yes.
Now we're about to get into distributive property. Now we're about to get into distributive property. Okay? We're about to look at Mr. Chain's vegetable garden.
Yay.
All right?
Alright.
All right. You're definitely about to use both of your colors. You're definitely about to use both of your colors. Are you ready?
Got it.
Okay, here we go. Turn your ears on.
Got it.
Here we go. Mr. Chain's vegetable garden is shaped like a rectangle.
Show it.
Okay? She grows, oh, it's a miss, not Mr. She grows tomatoes in one part, and then she grows corn in another part. What is the area of her garden?
Oh.
Okay, so now for the tomatoes, she has a 3 feet by 5 feet. So this side of her garden is tomatoes.
No, but
Next side of this, don't do that. The next side are her corn. It's 3 feet by 4 feet. Now, what I want you to keep in mind, when you build this, I want you to first build this on your desk. And number 2, I want the tomatoes and the corn right next to each other. Are we ready? Okay, so first, build the tomatoes in one color. Go. Build the tomato. I want you to build this on your desk. I want you to build this on your desk. I want you to build this on your desk. Scoot back some. Back up. Back up. Thank you. I want you to build this on your desk. So first, build her tomatoes. All right. When you get done building the tomatoes, I want you to put the corn right next to them.
Got it.
Okay, let's do the tomatoes in yellow. You can leave them out because you gotta do your corn. All right, start building your tomatoes. It's 3 feet by 5 feet.
So 3 fours.
Okay, so this is 1, 2, 3. Now you have to have 5. No, 3 feet by 5 feet. So that's 1, 2, 3, 4, 5. Now you have to finish filling this garden up. All this can't be empty. Fill it in. All right, now put your corn right next to it. This looks good. No. It's 3 feet, and then it's 5, and then 4. All right, take your marker, label your side lengths. Take your marker, label your side lengths. Take your marker, label your side lengths. Pause. I want these right next to each other. So I want the tomatoes and the corn. Nothing needs to be separated. They need to be right next to each other. Okay, let's count this for a second. Let's count this. Count, go.
1, 2, 3.
Okay, so that's your 3. Go. 1.
1, 2, 3, 4, 5.
Okay, so these are your tomatoes, yes? Okay, do you see your tomatoes? All right, so now I want you to think about your corn. Your corn is 4 feet. So with your purple, I need you to add the corn on there. Add the corn. Listen. That's good, Mackenzie. Okay, so now give me distributive property. What will be the equations? This is still not right. No, you need to fix it. It needs to be 3 feet and 5 feet in one color, and then you add on the other color. I know you can do it. Use the distributed property. And I need you to draw what will be the equation. So first do the pink side, then do the blue side. So first do the pink side, then do the green side. All right, make sure you put your parentheses, this is good. Do your parentheses. Okay, we already know it's 3. So it's 1, 2, and then 3. Okay, this is the corn. And then it's supposed to be how long, how wide? 4, okay, so let's count.
1, 2, 3, 4.
Okay, finish building. Don't separate them, keep them together. Now, label your side links and give me the distributed property. What would be the equation for the pink side? You don't have 3. You're supposed to start with 3. 1, 2, 3, then 1, 2, 3, 4, 5. Then 1, 2, 3, then 1, 2, 3, 4. Yes. All right, so now let's label the side lengths.